Hello students, welcome back to my channel Learn with Divya. So today's video will be continue from the last video. So let's get start. So today's topic is preparations of alcohol. Preparation of alcohol is of many types, but I will teach only 5 types preparations of alcohol. First is alkyl halide, second alkene, third is alkenes, four is carbonyl compound, fifth is Grignard reagent. Okay. So first from alkyl halide hydrolysis. Alkyl halide on heating with a dilute aqueous alkali give correspond alcohol. Better yield are obtained when alkyl halide are heated with moist silver oxide. Means bromoethane react with sodium hydroxide. The product will come ethanol plus sodium bromide. Second one is from alkenes, means hydrations. The addition of water molecule across the double bond in alkene is called hydration of alkenes. This method is useful for preparation of secondary and tertiary alcohol. The addition of water to unsymmetrically alkanes take place according to Markovnikov rules. The only primary alcohol that can be prepared by this method is ethyl alcohol. As alkanes are easily available, this method is used for industrial preparations of alcohol. Hydration of alkene is carried out by passing an alkene through cold concentrated sulfuric acid to give hydrogen sulfate, which on heating with water gives an alcohol. You can see in this reaction, ethane is react with sulfuric acid. In the product will come ethyl hydrogen sulfate, and the presence of water and heat, the ethanol are give plus H2SO4. Third one is from alkene hydroboration oxidation. The diborane react with an alkene to form a trialkyl boron as an addition product, which is then oxidized to an alcohol by hydrogen peroxide in the presence of dilute sodium hydroxide. You can see the propene react with diborane. The product will come tripropyl borane. Second one reaction, you can see tripropyl borane react with hydrogen peroxide. The product will come propane 1-ol. What is hydroboration in this process? So hydroboration is a oxidation leads overall to hydration of an alkene. In this reaction, alcohol is obtained in excellent yield. The addition of diborane to the double bond take place in such a way that the boron atom get attached to less substitute carbon. In this reaction, an alkene is converted into an alcohol with isoselective opposite to that of acid catalyzed hydration. It's look like that the addition of water take place according to anti-Markovnikov rule. A more convenient hydroborating agent is a boron tetrahydrofurane BH3-THF complex. It is very reactive and adds to alkene within minutes to 73 Kelvin. Tetrahydrofurane is used as a solvent. Fourth one is carbonyl compound reaction. How can we find product will come in a carbonyl compound in the presence of carbonyl compound reactions? So carbonyl compound reaction, aldehyde can be easily reduced to primary alcohol while ketone to secondary alcohol. Tertiary alcohol cannot be obtained by this method. Hydrogenation is carried out in the presence of catalytes such as a finely divided nickel, platinum or palladium. Next one is from Grignard reagent. All the 3 types of alcohol can be prepared by this method. An aldehyde or ketone undergoes nucleophilic addition of Grignard reagent in the presence of dry ether to form a complex which on acid hydrolysis give an alcohol. Example, methanol react with a methyl magnesium iodide in the presence of dry ether to give a complex which on acid hydrolysis give ethanol. Second one reaction, ethanol react with methyl magnesium iodide in presence of dry ether to give a complex which on acid hydrolysis gives propane to all. So next topic is reactions of alcohol. Alcohol are natural to litmus. In fact, alcohol are boranestate acid. They donate protein of OH group to strong base. Alcohol also behave as Lewis by donating lone pair of electron present on oxygen. The CO and OH bond in alcohol are polar, and hence alcohol are quite reactive. First reaction, the reaction involving breaking of OH bond. Okay, so reaction involving breaking of OH bond, it's a two type: action of metal and esterifications. The first is action of metal. An alcohol react with active metal like sodium, potassium, aluminium to corresponding alkoxide, liberate hydrogen gas. Example, C2H5OH plus Na. Product will come C2H5ONa plus H2. C6CH3 COH plus 2 aluminium gives CH3 whole cube CO cube Al plus 3H2. This reaction explains acidic nature of alcohol. This acidic nature of alcohol is due to the polar nature of OH bond. Alkali group is electron release group and increasing electron density on oxygen, which result is decreasing in polarity of OH bond. As number of alkyl group increasing, acidic strength of alcohol decrease. For the above reaction, it is noted that the water is better proton donor than alcohol, and alkoxide ion is better proton acceptor than hydroxide ion. Thus, alcohol are weaker acid than water, and alkoxide ions are stronger base than hydroxide ion. Next reaction is esterification. Esters are obtained when alcohol react with carboxylic acid, acid chloride, and acid anhydride. The reactions are reversible, hence the reaction with acid anhydride is carried out in presence of concentrated H2SO4 as a dehydrating agent. So next one is related to alcohol. It's very important topic. Sadzev rule. In a dihydrohalogenation, what is Sadzev rule? Sadzev rule in a dihydrohalogenation or in the dihydration of the alkene formed by the elimination has a greater number of alkyl group attached to the double bond carbon atom. A tertiary alcohol is easily dehydrated by heating with 20% H2SO4 at 363 Celsius. So reaction will be 2-methyl propane to all give 2-methyl propene. So last topic is uses of alcohol. Methyl alcohol is used as an industrial solvent for oil, fats, gum, cellulites. It is used for a dry cleaning and preparation of perfumes, varnish, and also as anti-fertilizer agent and automobile radiator in a cold countries. Methyl alcohol is used as a starting material for the preparation of methyl chloride, dimethyl sulfate, and formaldehyde. It is used in nature ethanol and make ethyl alcohol unit for drinking. Ethyl alcohol is used as a solvent for dyes, oils, perfume, cosmetic, and drugs. A mixture of 10 to 20% ethyl alcohol with petrol is used as motor fuel. Ethyl alcohol is used to prepare soil fuel, which is a dispersions of ethyl alcohol in a calcium acetate. It is easy to transport, and ethyl alcohol as a low freezing point. It is used thermometer. It is maintained constitute of beverage. It is an effective topical antiseptic and is used as ingredient in many mouthwash. It kills microorganisms on surface and in the mouth, but it is low toxic, does not kill the cells of the skin or mouth tissue. Ethyl alcohol is used starting material for the preparation of iodoform, chloroform, acetic acid, ether, etc. Ethyl alcohol is used as a fuel. It is very important question. What happens when vapor of primary, secondary, and tertiary alcohol are passed over heated copper at 573 Kelvin? Answer: when vapor of primary, secondary and tertiary alcohol are passed over heated copper at 573 Kelvin, dehydrogenation of primary, secondary alcohol take place while tertiary alcohol undergoes dehydrogenations to give an alkene. So primary alcohol, what we give? Ethanol in the presence of copper and 573 Kelvin. So what happen? The product will come ethanol and plus hydrogen. Secondary alcohol, propane to all, in the presence of copper and 573 Kelvin, the product will come propanone, okay, plus hydrogen. And tertiary, the product will come, product will react to methyl propane to all in the presence of copper 573 Kelvin. So product will come to methyl propane plus water, okay. So I will meet you in next video. Please like, share and subscribe my channel. Bye bye.